So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir. Now in today's lecture we are going to see how to count a distinct element in every window of size k. Here what you can do, instead of a window you can replace this word as subarray. So we have to count the distinct element in every subarray of size k. So let's take one array. So here the subarray size is 4. So if we take a look at the first subarray, here the count of the distinct element is 3. If we go forward, the count of distinct element here is 4. Then for this we do have 4 again, and for this we have 3. Okay, so this we need to return as an answer. Okay, now the question arises that since we will be returning the multiple values, okay, in the form of an array, so what will be the size of this array? Okay, now here let's say size of an array is n and window size is k. Okay, so the number of subarrays will be n minus k plus 1. So these are the number of subarrays will be formed when the size of an subarray is k. So the size of the resultant array will be this. So when we are going to make a resultant array, this size should be n minus k plus 1. So if we take this, here the value of n is 7 and value of k is 4. So 7 minus 4 plus 1 will be 4. I hope you got this. Now let's take one more example. Now here the value of k is 3. Okay, so if we take a look at the first subarray of size k, we can see that all the elements are same. Okay, so here the count of the distinct element in the first subarray will be simply 1. Similarly, if we take a look at the second subarray, again 1, for third again 1. Okay, so this we need to return. Now if we take a look at this third example, here the value of k is 2. Okay, now we can see that all the elements are distinct, right? 10, 20, 30, 40, 50 and so on. So it's simple. Count of the distinct element in first subarray will be 2, then 2, 2 again, 2, and for this also 2. Okay, so this we need to return in the form of an array. Okay, I hope you got this problem. Now let's see that how we can solve this problem. Now before going forward, let's try to find that how we can find the count of a distinct element in a simple array. Okay, so let's take one example as this only. Now here we can see that the count of the distinct element in the whole subarray is simply 4. 1, 2, 3 and 4. Okay, now when we want to find whether this element is distinct or not, okay, what we can do, we can simply go backward, that means on the left hand side, and try to search whether this element is present or not. If it is present, then this element is not distinct. Okay, similarly, if you try to find whether this element is distinct or not, simply go on the left hand side to search for the element 4. If we don't found any element, okay, then this element is simply distinct. So using this approach only, we are going to solve this problem. So for this case, for I will be 0 and it will be gone till less than n. Okay, now here I'm going to take one flag is distinct, since we are going to find whether each and every element is distinct or not. So initially the value of the flag will be true. Now another for loop in which here variable will be j. Okay, and it will be coming from I minus 1 and going till 0. Okay, less than equals to 0. Similar. Now here we are going to check if a of I is equals to a of j. If we found that element is equals to previous element, okay, then it's simple that that element is not distinct. So is distinct should be false. Okay, and simply break from that loop. That's it. Now, since we are out of the second for loop, we are going to check whether is distinct is true or not. So if is distinct, if it is true, okay, then only we are going to do count plus plus. Otherwise, simply ignore. So this is a brute force approach to find or to count the distinct element in a simple array. I hope you got this approach. Now, let's come back to our main problem. Since here we are going to find the distinct element in each and every subarray, so the approach is little bit different. Let's put this here. Now, I hope you already know that how to find a subarray. Okay, so I'm going to use a while loop here. While end should be less than n. Okay, initially the value of s will be 0 and e will be k minus 1. So what I mean to say, s will be here, and since the value of k, let's take it as 4, e will be here. Now we are going to find the distinct element, the count of the distinct element from this to this. Okay, now here we are going to call this for loop by passing the array, the start index and the end index. Okay, so find distinct, pass the whole array, the start index and the end index. Okay, and whatever will be the answer, let's store it in count. Okay, now the resultant array will be answer is equals to count. As I said that the resultant array, the size of the resultant array will be n minus k plus 1. Okay, so due to that I'm putting it s here, because initially the value of s will be 0, and when and till the end the value of s will be simply 3. Okay, now s plus plus e plus plus. After getting the first value, simply increase the s and the e. Now since I'm using this s and e, so this will be little bit change. Find distinct a, s and e. Okay, now here it will be coming from s and it will be gone less than equals to e. Now here also in the second for loop it will be s coming from I minus 1 and it will be gone till s. Okay, that's it. Now you can dry run it by yourself because it is a very simple approach. Okay, I already told you that how this is working. Okay, and this is a simple code. Now you can dry run it by yourself. Okay, let's come to the time complexity of this approach. Here we can see that in this while loop, okay, e is pointing here and it will be gone till n. Okay, now if you want to find a distance from e from here to here, it is simple, n minus e plus 1. Okay, now initial value of e is n, now the initial value of e is k minus 1, so n minus k minus 1 plus 1. This and this will be get cancelled, so n minus k. So this while loop is running from this while loop is running n minus k. Okay, and if you see, this function is having two for loops and each for loop is running approximately to k time, because the start and end index is s and e and the distance between s and e is simply k, right, because of this subarray. So the k into k, that will be k square. Okay, so the time complexity will be n minus k into k square. Okay, this is nothing but n only, approximately n. So n into k square is the time complexity. Now here we can see that the time complexity is very huge, so we have to optimize this. Now if you take a look of this function, okay, here we are going to see two for loops. Okay, if we want to optimize this approach, I always target this inner for loop. Okay, actually eliminate this. I try to eliminate this for loop. Okay, now if we have this subarray, okay, so we are going to check for each and every element whether that element is distinct or not. Okay, so if we want to eliminate this, what if we introduce the hash set? Because in the previous video I have told you that how the hash set can be used to find the unique element. Okay, so if we are standing here, okay, and the boundary is here, is this. Okay, if we are standing here and if we put this element in the hash set, then one will get stored. Then we move forward, two will be stored. If we move forward, if we want to store this one, it will be not stored, because in hash set only the unique element are stored. And if you move forward, the element is 3, so 3 will be stored. So in the hash set only 3 values are stored. Okay, so we can simply say that in this subarray 3 elements are distinct. Okay, so we are going to eliminate this and introduce the hash set. Okay, so let's see how we can do this. Approach 2. Here everything will be same, but instead of the second loop, hash set will be there. So int find distinct. Here I'm going to get an array s and e. Now let's create a hash set. I hope you know that how to create a hash set. If you are a C++ or a Python programmer, okay, you can find it of your own. In C++ we do have uh, unordered set. Now for I will be coming from 0, I will be coming from s, and it will be counted less than equals to e. Now hash set dot add a of I. That's it. Simple, right? It's now simply written hash set dot size. That's it. Okay, and we know that if you want to find the size of the hash set, it is basically order of n, order of 1. Now simply copy this. I'm going to paste it here. Now the if you see the time complexity of this value will be same, n minus k. Okay, we can simply approximate it to order of n. Okay, and the time complexity of this will be order of k only. Okay, so n into k will be the time complexity of this approach, which is optimized. Now let's take one more example. Now in the previous lecture when I was teaching about the subarrays, in some of the problems I introduced this sliding window approach as well. Okay, so let's say here can we optimize the solution by using sliding window approach as well as the hash set. Okay, so initially the s will be here and e will be here because the value of k is 4. Now let's create the hash set. Okay, now the thing is that since this is a first window. Okay, I'm going to put all the values into the hash set. So this will be 2, then 5, 9 and 8. After this, I'm going to simply return the size of the hash set. Here in this case is 4. Okay, because all the elements are unique. Okay, in this window the answer will be 4. Now let's move the window. S will be year, E will be year. Now the thing is that when I move S to 0 to 1, okay, this element will be deleting. Okay, and E will be moving from 3 to 4. So this value will be coming into the hash set. Okay, so let's first delete this value 2. So if I delete this value 2, this is the status of the hash set, and I'm going to introduce this value, okay, 9. But when I'm going to insert this value 9 into the hash set, I can see that 9 is already present. Okay, so let's ignore. Now for this window, what will be the size of the hash set is 3, right? So simply return 3. I hope you got this. Now let's slide our window again. Okay, now the window is this to this. Okay, now whenever I'm going to slide the window, I'm going to delete this previous element. Okay, so let's first delete this element and introduce this new element. Okay, introducing the new element, that means inserting that element into the hash set. Okay, now after removing and inserting, what is the size of the hash set is 3. So return 3. Again, let's move forward. S will be here, E will be here. Now the window is this from 3 to 6. Now first let's delete this previous element, which is this. Okay, so I'm deleting this element and introduce the new value, which is 5. Okay, so 5 it is. Now the thing is that for this window, the count of the distinct element is 4, right? But I can see that the size of the hash set is 3 only. Okay, why this? Because when I deleted this 9, okay, this 9 is also deleted. Okay, so this is the error in this approach. Hence, using the sliding window plus hash set fails. Now how can we correct it? When I was looking at this window, okay, I was deleting this 9. Now till this point, the frequency of 9 was 2. And when I was deleting, when I'll be deleting this 9, the frequency will be 1. Okay, now the thing is that in the frequency array, okay, if the frequency of the element is 0, then only I will be removing that element from that container. Okay, let's say this is a container. Hence, since I'm going to use, since I'll be needing the frequency container, therefore I will be using frequency map or hash map. Okay, so let's see that how we can solve this problem using the sliding window and hash map. Okay, so S will be here, E will be here. Now since this is a first window, I will be inserting all the elements into the hash map. So the frequency of 2 is 1, for 5 it is 1, for 9 it is 1, for 8 is also 1. Okay, what will be the size of this hash map? It will be 4 because 4 elements are present. Let's slide our window. S will be here, E will be here. Now as I said that when I'm moving the window, this element will be deleted. Okay, but here in this case I will be reducing the frequency of that element by 1. If the frequency of that element will be 0, then only I will be removing it. So the frequency of this element will be now 0. Hence I need to remove this 2 from the hash map. Okay, now let's introduce this new 9. Introducing this new 9 into the hash map is nothing but increasing the frequency of that element, hence 2. Now what is the size of the frequency map? It is 3. Okay, so for this window the answer is 3. That means the count of the distinct element. Again, let's slide our window. S will be here, E will be here. So let's first delete this element. Deleting this element means reducing the frequency by 1. So this will be 0. If it is 0, simply remove it from the hash map or the frequency map. Let's introduce this new value, which is 4. Okay, so I'm writing 4 here with the frequency of 1. What is the size of the hash map? It is 3. So for this window, the count of the distinct element is 3. Let's move again. Let's move forward. S will be here, E will be here. I will be removing this 9. Removing this 9 means reducing the frequency of that element by 1. So this will be 1. Okay, and since we can see that the frequency of this element is 1, not 0, so I can't remove it. Now I'm going to introduce this 5. So 5 will be here with the frequency 1. What is the size of the frequency map? It is 4. So 4 is the answer. Let's move forward again. S will be here, E will be here. Again, reduce the frequency of that element. This is 8, right? So this will be 0. Hence, I will be removing this 8 and introducing this new value, which is 4. If I introduce this new value, or if I insert this new value into the hash map, the frequency will be 2. Okay, return the size of the hash map, it will be 3. Okay, let's move forward. S will be here, E will be here. Okay, now removing this 9. Okay, if I remove this 9, the frequency of this 9 will be 0. Hence, remove this element simply from the hash map. Okay, and introduce this new 5. If I introduce this new 5, the frequency will be 2. Return the size of the hash map, this will be 2. So we can see that of this window, the count of the distinct element is 2. Okay, let's move forward again. S will be here, E will be here. Okay, first reduce the element, reduce the frequency of that element by 1. So we will be reducing the frequency of this element. Okay, 4. So this will be 1. Since it is not 0, okay, I can't remove it and introduce this new value. So put 18 here and the frequency is 1. Return the size of the hash map will be 3, and that's it. If we move forward, that means S will be here, E will be here, the while loop will be failed, hence we need to terminate. Now we are going to return this. Let's see that how we can code this problem. First, create the hash map. So hash map integer hmap equals to new hash map. Okay, now for the first window, simply run from 0 to k minus 1. So for I will be running from 0 and it will be counted k. If hmap dot contains key, if the hash map is containing that element, we simply need to increment the frequency of that element. So a of I if that element is not present into hash map, then simply do else hmap dot put a of I and 1. That's it. But if it is containing, if that element is present into the hash map, then we need to first take that frequency. Okay, how we can take this? Simply do old frequency equals to hmap dot get key AFI, then increase that old frequency by 1. So, and after increasing, we also need to put that value again to the hash map. So hmap dot put AFI comma old frequency plus 1. Here you can use get or default method as well. Okay, but this is a very simple technique. Now, since this is a first window, okay, the resultant of 0, the resultant array, which will be at the start position, will be our answer hmap dot size. Okay, so this is what I'm trying to say. When this was the first window, okay, so I was putting all this value into the hash map. Okay, and after that I will be returning the size of that hash map. Okay, so after the first window, my resultant of 0 will be simply hash map of size. Okay, now s will be 1 and e will be k, because I have figured it out the answer of the first window. While e is less than n, now here I'm sliding the window, okay, by 1. So as I said, first we are going to remove the previous element. Okay, so we need to take the old frequency of that previous element. So old frequency equals to hmap dot get key by passing a of s minus 1, because s minus 1 contains the previous element. New frequency will be old frequency minus 1, and here we are going to check if new frequency is equals to 0. At that time we are going to remove that element from the hash map. So hmap dot remove a of s minus 1. I hope you got this. But what if the value or the frequency, what if the frequency is not equals to 0? Else hmap dot put s of, sorry, a of s minus 1 comma new frequency, because the new frequency is not 0. So we are going to reduce it by 1 and then again store it. Now this was the approach for removing the element. Now let's introduce the new element. If hmap dot contains key a of e, okay, if the new value is already present into the hash map, okay, then we need to increase the frequency of that. So old frequency is equals to hmap dot get key by passing a of e, then do hmap dot put a of e comma old frequency plus 1. That's it. Okay, else if that element is not present into the hash map, then we have to simply insert that element. So hmap dot put, since this is a algorithm, okay, that's why actually I'm using this arrow symbol. Okay, a of e comma 1. Now our resultant array of s is equals to HMap dot size. Okay. After getting the value or the count of the distinct element of that window, simply do S plus plus and E plus plus, sliding the window. That's it. Okay. Now, if we think about what will be the time complexity of this while loop, we can see that here E is running from K to N, right? See, initially the value of K is 4, right? So E is pointing to 3, okay, because of the 0 value index, and it is going till N, okay. So if we talk about this, N minus E plus 1, okay, the value of E is K. So N minus K plus 1, okay. So this is the time complexity of the while loop. N minus K plus 1, okay. And for this, the time complexity of this for loop is simply K, okay. Now if you combine this, K plus N minus K plus 1, this and this will get cancelled, okay, which is N plus 1, okay. So due to that, the time complexity of this approach will be order of N only, okay, because we are neglecting the constant. And what will be the time space complexity? It will be order of N, because we have used the hash map, okay. From order of N into K square till order of N, we have optimized this approach, okay. So using the hash map and the sliding window, we can solve this problem by the time complexity of order of N and the space complexity of order of N. Okay, I hope you got this. If you didn't, I'll advise you to please try run it by yourself. Okay, so that's it from my side. I'll see you in the next video. Till then, keep practicing.